Alright, so this lesson covers 8.3, day 1, solving trigonometric equations using algebra techniques. You'll notice that I've given you a unit circle because we're going to be solving equations where you're figuring out the angle that's related to a specific ratio. So let's go ahead and talk about what I have up here. So we're saying using algebra techniques to isolate trig functions. So when we think about equation solving in Algebra 1, sometimes we're working with things that are pretty straightforward, like, for example, get this to right, things like 2x plus 1 equals 5. Now, when you're in Algebra 1, you use inverse operations. You do the opposite. You subtract 1 from both sides, you divide by 2, and you get an answer of 2. Nothing too difficult. In trigonometry, it's the same idea, but you're going to be isolating the trig function. You'll isolate the sine of x, or the cosine of x, or the tangent of x. Another option that you have in Algebra 1 is if you're squaring something. So, for example, if I had 2x squared equals 16, you divide both sides by 2, and of course you get 8, but then you have to take the square root. So you have x equals, when you simplify the radical 8, you get 2 square root 2, but in the context of solving an equation, you get 2 roots of plus or minus. So you can also use square root techniques in trig to isolate your value. Here's the catch though. We've got 4 quadrants that we're working with, and so there's possibilities of maybe 4 answers, maybe 2, maybe none, maybe 1, maybe 3. So you can have anywhere between 0 and 4 solutions. The number of solutions is going to depend on the domain restrictions of the problem. Jonah, can you go ahead and close the door? All right, so we're going to go ahead and try some examples. When we think about solving equations, what you're really doing is if you had to graph something, you're figuring out where it crosses the x-axis. Essentially what we're doing when we're trying to solve something that says cosine of x, we're really thinking about the graph of where it crosses the x-axis. It's just that we use the unit circle or triangles to find those values. So it says solve all examples for all solutions over the interval of 0 to 2 pi. So in other words, whatever that ratio is that you have, you can look at any of the 4 quadrants that satisfy that ratio. So for this one here, cosine of x equals 1/2. Well, cosine of x is already isolated. So you're going to go up to your unit circle to figure out what angles have cosine ratios of 1/2. So anywhere you see the cosine being 1/2, you're going to use that particular angle. So we've got the 1/2 here, got let's see, those are negative, and down here these are positive. So what 2 angles correspond to those? So you've got pi over 3, and you've got 5 pi over 3. So you get 2 solutions in this particular case. I'm going to write that down. Pi over 3 and 5 pi over 3. Now we didn't use anything from the other quadrants because those cosine ratios were negative. Now you'll notice that this restriction is over the interval from 0 to 2 pi. In other words, that's the entire unit circle that you're looking at. Now later on we're going to talk about something called general solutions, where you have to make a generalization about what multiples are all solutions, because remember, when you're looking at a graph, these are infinite. All right. You guys ready for example 2? All right. Example 2. So the first thing you have to do is make sure that you're isolating your trig function. We're going to divide both sides by 2 here. So you're going to have sine of x equals 1/2. And then go up to your unit circle and locate all of those values that would be related to 1/2 in the sine function. And that should be pi over 6 right here. And we also have 5 pi over 6, which is right here. So those are your 2 solutions for that one. All right, now some examples you'll get more solutions for, and some you'll get less. Now this example 3 and example 4 both actually have 2 solutions, but there's a little bit more steps to them. So for this first one, example 3, we've got -2 cosine x plus 4. You're going to isolate that cosine by subtracting 4 from both sides. And then, of course, your last step is divide by -2. So cosine x equals -1/2. go up to your unit circle and locate all cosine ratios of -1/2 and write down those corresponding angles. So there are only two that have cosine ratios that are negative, and that's going to be 2 pi over 3 and 4 pi over 3. Example 4. So we have a tangent equation, but you'll notice that there are tangents on both sides of the equation. You also have this minus radical 3. So what I'm going to do is I'm going to move the tangent functions over to the right-hand side, and that way I can leave this negative radical 3 on the left by itself. It saves a step. So if I subtract 5 tan x from both sides, I get negative square root 3 equals negative 3 tan x, and you're going to divide both sides by negative 3. So you'll have tan x equaling a positive square root 3 over 3 because you're dividing by negatives. Now for this one, tangent, the regular tangent function is only going to be positive in 2 of the quadrants. And that's going to be in the first and third quadrants. So you're going to have to figure out which ratios give you square root of 3 over 3. Now if you go up to the first quadrant, when you look at pi over 6, you can go ahead and try this first relationship that's up here to see if you're going to get square root 3 over 3. Keep in mind, you're not going to get the pi over 4 because when I look at the sine and cosine, those ratios are going to give me 1s or negative 1s in all of the quadrants, so that's not even an option. Just try pi over 6. If it doesn't work, then you automatically know it's going to be pi over 3. So let's do a quick calculation. Now I'll only do the practice calculation for this value one time, and then later on I'll just write them down. But when I look at pi over 6, the values are square root 3 over 2 and 1/2. And so if I do sine divided by cosine, I have 1/2 divided by square root 3 over 2. Keep change flip. So 1/2 times 2 over square root 3. Your 2's cancel. We have 1 over square root 3. And of course, when you rationalize that, you're going to get square root 3 over 3, which matches what we have over here. So that definitely is pi over 6 in that first quadrant. But if you go to the third quadrant, you'll also see that you have a matching value here. So if we have pi over 6, when we go over into this other quadrant, we also include the 7 pi over 6. You can see that they're diagonal from each other because they have the same ratios, and negative over negative is positive. So you're going to want to add that value onto your solutions, which is 7 pi over 6. All right, example 5 is a square root problem because you have originally a squared function. So we're going to isolate the squared function by adding 3 to both sides. So we have tan squared x equals 3. And to isolate it just to tan x, you're going to take the square root of both sides. So we have x, the tangent of x equals plus or minus the square root of 3. So you're going to end up with 4 solutions because you're going to take all of the positive ratios square root 3 and all of the negative ratios that are square root 3 as well. Now we already know that it wasn't pi over 6 for this example because if you go up to example 4, the pi over 6 ratio is square root 3 over 3. So in the first quadrant, it's got to be the other multiple of 30, which is pi over 3. Pi over 3. And you can quickly go up to the top and find all of those values that are related to that. So let me get rid of these. All right, so we've got pi over 3, which is right here. And notice we have the relationships 1/2 square root 3 over 2. But you can also use the negatives because we just said that the results will be plus or minus. So anything that has cosine 1/2 and then sine square root 3 over 2, even if it's negative, also satisfies this. So notice that I've got the one that's down in the third quadrant, which is going to be your 4 pi over 3, which is diagonal from that, like this, because those match up. And then over here in the second quadrant, we've got the 2 pi over 3 because those match up as well. And then if you go into the fourth quadrant, right here, you've also got your 5 pi over 3. So you've got all of the 4 solutions because I noticed that all the sine and cosine ratios are the same except for the pluses and the minuses. All right, example 6. Go ahead and do that one on your own. So pause the video, and when you finish, check your answer. I did forget to write down the rest of the solutions for example 5 that I circled in the unit circle. So that should include 2 pi over 3, 4 pi over 3, and 5 pi over 3. All right, so for example 6, you should have added 2 to both sides, divided by 4. You need to reduce your fraction on the right-hand side first before you take your square root. So you have sine squared x equals 1/2. Square root of both sides. So we have sine x equals plus or minus. Square root of 1 is 1. Square root of 2 is the square root of 2. Rationalize your denominator. So you have square root 2 over square root 2, which is ultimately square root 2 over 2, and that is plus or minus. You're going to find that in 4 of the quadrants, all 4 of them. Happens at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. You're including all positive and negative ratios. All right, example 7. Notice I've got another unit circle here for you. So we're going to start the same way. We're going to subtract 4 and divide by 2. So we've got 2 secant x equals negative 4. Divide both sides by 2. So you've got secant x equals negative 2. Now from here, you're going to want to do the reciprocal because of the fact that secant and cosine are reciprocals of each other. So instead of writing secant x, I'm going to write cosine x, but I'm going to take the reciprocal of the other side, the right-hand side. So this becomes negative 1/2. And then all we're looking for is any cosine angle. The ratio is negative 1/2 for any of the particular angles. So that only happens in 2 cases. Happens at 2 pi over 3 and 4 pi over 3. So I'll go up here and circle those as well. So I've got 2 pi over 3, and this is a little bit covered up there. There's your negative 1/2 right there. And then 4 pi over 3, here's your other negative 1/2. All right, number 8. So we're going to go ahead and solve this just like we would a regular 2-step. You're going to add 2 to both sides. Divide both sides by 4. Reduce the right side. So we have 1 over 2. And then we're going to go ahead and take the square root of both sides. So eliminate that squared function. And we're going to say that the cosecant of x equals plus or minus square root of 1 over 2, which is going to be 1 over square root 2. I don't want you to rationalize it yet because we're not going to work with cosecant anyway. We're going to work with the sine function. So I'm going to go ahead and flip it over. So the reciprocal is the sine of x equals plus or minus square root of 2. And you can write square root of 2 over 1 if you want to. It makes it easier. If you had rationalized it, you'd have to just do more work anyway. So this one's pretty easy to flip over. However, if you go to your unit circle, you don't have any sine ratios that are square root 2. So what you need to do is look at a triangle for this. Now, there are 2 ways to approach this problem. We can discuss the domain, or we can discuss it in terms of a right triangle. I'll discuss the domain after. So since I don't have any ratios within the unit circle that are square root of 2, so I'm going to look at a right triangle. So where we have the angle x, and this is technically square root plus or minus square root of 2 over 1. And remember, sine is opposite over hypotenuse. Now I'm not going to worry about the plus or minus. I'm just going to use the positive values in my triangle. So opposite would be square root 2, and then of course the hypotenuse would be 1. What you'll notice, though, is that you have a leg value that is greater than the hypotenuse. this, and that's impossible. So this is, I'm going to write impossible, because logically you can't have a hypotenuse that's smaller than a leg. So this one has no solution. In other words, if I graphed the function on the graph of the xy axis, you would not have anything that crossed the x-axis. So additionally for this problem, I could have saved myself the trouble of working in the right triangle because of the fact when I look at the original problems as well as when I look down here at the final one. So when I look at a ratio for sine anyway, for a sine function, the range is between -1 and +1. If I look at this, if you have any kind of a sine function, the domain has to be less than or equal to 1 and greater than or equal to -1. And square root of 2 falls outside of that restriction anyway. So immediately would have been excluded. Pause the video and complete the last 2 problems on your own and check them when you're finished. Go ahead and check your answers to number 9 and number 10.